Welcome to the Inductive Statistics course by International Business School of Hanze University of Applied Sciences.
We are going to learn what is the binomial distribution and what is the Poisson distribution and the normal distribution. And for the normal distribution, it means it's a distribution of the continuous and random variable. And besides these three distributions, we will also learn from binomial distribution to convert into normal approximation. So these are today's learning content. Let's first take an overview of what we are going to learn. Binomial distribution means this is discrete data. And for this discrete data, you have a range. And Poisson distribution is also for the discrete data. But in this case, you only know the mean, the average of that. And for the normal distribution, as mentioned before, it is for the continuous data. And for the binomial distribution, we can use this equation. In this equation, n means in total how many times you have. And r means the probability of success. We can also say the probability of one side. And for the Poisson distribution, we use this equation. In this equation, there is one sign which is called lambda. And that refers to the mean of the discrete data. And the normal distribution, it's about the bell-shaped curves. And we use this equation to calculate the z-score. And from the z-score, we can calculate the probability. And for these three distributions, binomial distribution, we use the table A3 in the book. And for Poisson distribution, we use the table A13 in the book. While for the normal distribution, we first check the z-score and use this z-score to check table A1 to get the probability. Now let's look at them one by one. First, it's the binomial distribution. Let's look at the question on page 249. That's question 522. And in this question, it is said, Harley is conducting his monthly spot check of automatic transmissions. In this procedure, 10 transmissions are removed from the pool of components and are checked for manufacturing defects. Historically, only 2% of the transmissions have such flaws. The question asks about what is the probability that Harley's sample contains more than 2 transmissions with flaws. In this question, we have already known the sample size is 10, and the probability is 0.02. And we want to know what is the probability that among these 10 products, we have more than 2 products which have got the transmission flaws. And we need to go to the table A3. In order to get the probability, you need to go to the book and to check the table. And in this case, we go to A3 table. That is for the binomial distribution. And from this table, you can find, first is the normal probability. And in that it will be 0.02. So you first need to find this number. And after that, you look at when n equals 10. So n is here when it equals 10. And what will be r? When r first is 0, 1, and 2. And what will be the number here? And from the table, we can find that the number for r when it is 0, that will be 0.8171. When it is 1, that will be 0.1667. And when it is 2, 0.0153. Yeah. So from the table, you can get these 3 numbers. From the table, we have known that if the r is 0, the probability is 0.8171. If R is 1, the probability is 0.1667. And when it is 2, the probability is 0.0153. So the probability that we have it more than 2, that means you need to add them up, 0, 1, and 2. For each probability, you add them up. And then you use 1 minus that. And then you get the probability more than 2. Then the final answer is 0.009. Because when you add probability, when R is 0, R is 1, and R is 2, then you get a probability that we have it less than 2 and equals 2. And you use 1, that means 100%, to minus less than 2 and equals 2. Then you get the probability for more than 2. Now let's look at the second question. What is the probability that none of the selected transmissions has any factorial flaws? That means R is 0. We still use n equals 10, p is 0.02. And we check the table. And we get a solution. When R is 0, that means none of these selected products has flaws. Then the probability will be 0.8171. That means if you choose 10 products, you will get 81.71% that none of the products has any flaws. After the binomial distribution, now let's go on looking at Poisson distribution. Poisson distribution is when it is discrete data, but it is only you only know the mean, lambda. Let's look at question 531 on page 256. Donna has estimated that on average 8 coughs occur just before her music performance. If she coughs more than 5 times, she will not come to perform. What is the probability that she will play tonight? So in this question, we know that on average, Donna coughs 8 times before her music performance. So the mean is 8. That is lambda 8. And we want to know what is the probability that today she coughs less than 5 times. Because less than 5 times means that she can still come to perform. She will play tonight. And then it is Poisson distribution, so we need to go to table A13. And in this table, we can find that when lambda is 8. To solve this question, you need to go to table A13. That is for the Poisson distribution. And from this table, you will find the first row, it is lambda. That is the mean. And you try to find when lambda equals 8. And what kind of probability you want to get? First, we want to get when lambda is 8, what will be the probability when R is 0? So you go to 0, and then you will find the number here. When it is 1, you will find the next number. And you do it for the next until 5. So you will get the first number 0.0003. And the second, when R is 1, 0.0027. When R is 5, 0.0916. And what will be the R is 0, and R is 1 until R is 5. What will be that probability? So we find that if she coughs 8 times on average, that the chance that she didn't cough at all is around 0.03%. And the chance that she will cough only once today is 0.27%. So when we add them up, then you will find the chance that she coughs less than 5 times equals 5 will be 0.1912. That means she has got 19.12% to cough less than 5 times. So today she comes to perform. The chance is 19.12%. Now let's look at normal distribution. This is for the continuous data. And because the data is normally distributed, so we should have a bell-shaped curve. And from this curve, we can calculate our z-score. Z-score means x is the individual random variable. Use this random variable to minus the mean and divide it by sigma. This is the standard deviation. And we use table A1 to check the probability. Look at this question, 542 at page 270. We need drive shafts with a diameter of 5.1 plus and minus 0.05 inches. In stock, we have shafts with a diameter mean 5.07 and a standard deviation of 0.07. What is the probability of a stocked steel fit our requirements? In order to solve this question, we first need to understand what is the mean here. And the mean is 5.07, and with the standard deviation 0.07. And if we draw the line, 5.07 is the mean. And then we know, okay, 5.15, which is 5.1 plus 0.05. And that will be somewhere here, 5.15. And 5.15 minus 0.05, that will be somewhere here. And then you can calculate that. Calculate the first z-score. It comes from 5.05. So this number is 5.1 minus 0.05. To minus the mean, 5.07, and divide it by the standard deviation, 0.07. And you get your first z-score minus 0.29. This is a negative number because this comes from the random variable, which is lower than our mean. And we calculate the second z-score. It comes from 5.15. 5.15 comes from 5.1 plus 0.05. To minus 5.07, our mean, and divided by the standard deviation, 0.07. And we get our second z-score, 1.15. After you get your z-score, you can check the table A1 to get your probability. And we check the table and we find that when the z-score is 0.29, the probability will be 0.1141. And if the z-score is 1.14, the probability will be 0.3729. So when we add them together, because the probability only means from the random variable to the mean, what is the probability of this part? So 11.41% is this part, while 37.29% is this part. So we have to add them up. When you add them up, then you get 0.4870. That means 48.70% of our data fits our requirement. And that means less than 50% of our shapes fit the requirement. After we have known binomial, Poisson, and normal distribution, we will go further to look at how to convert binomial distribution into normal approximation. The first step is whether you need to check when n, your sample size, times p is larger or equals 5, and at the same time, your sample size times q larger or equals 5. If both conditions are met, then you can say we can use normal approximation. If one of the conditions is not met, and then you will continue to use the binomial distribution. So step 2, because for the normal distribution, you have to calculate what is the mean, what is the standard deviation. So in this case, you use your n times p, that will be your mean, mu, and n times p and times q, and then square root it. That will be your standard deviation. Step 3, you need to find your CCF. We call this is continuity correction factor. And when your x, the random variable, is larger than 3, then your CCF should be larger than 3.5. That means in the original data, 3 is not included. So you have to choose 3.5. When the original data says it is larger or equals 3, then you need to choose CCFX larger than 2.5. That means 3 will be included. And if x is smaller than 3, once again, 3 is not included. And then you need to choose smaller than 2.5. When x is smaller than 3, this time 3 is included. So you have to choose less than 3.5. So 3 will be included. And you can find the continuity correction factor, we always choose 0.5. After you know these 3 steps, and then you can go on to use the normal distribution to solve the questions. Let's look at one question on page 271. The question number is 5.47. On the basis of past experience, auto inspectors have noticed that 5% of all cars coming in for their annual inspection fail to pass. So 5% of the cars fail to pass. What will be the probability that between 7 and 18 of the next 200 cars will fail in inspections? In this question, we know that in total we have got 200 cars. And in the past experience, we know the probability is 0.05. If we know the probability of one side, we will know the probability on the other side of the coin. It comes from 1 minus 0.05. So if you have got 5%, the cars fail to pass. That means 95% the car will pass. And first step is to check whether it is allowed to use the normal approximation. You use n times p, so 200 times 0.05, and then you get 10, and 10 is larger than 5. At the same time, use n times q, 200 to times 0.95. You get 190, which is also larger than 5. So when both conditions are met, you said, yes, we can continue with this normal approximation. And the second step is to calculate the mean. N times p equals 10, and this is your mean, which is called mu. And the standard deviation sigma comes from 200 times 0.05 times 0.095, and then square root it. Then you get 3.08. This is your standard deviation. And we want to know what will be the probability between 7 and 18. That means larger than 7 and smaller than 18. We need to convert that into the CCF. Because 7 and 18 both are not included. So larger than 7 means you need to larger than 7.5. Smaller than 18 means you need to choose 17.5 so that 18 will not be chosen. And then you draw the bell-shaped curves. Visualize it, and you can find the first z-score comes from the individual variable 7.5, which is the CCF you have just selected, minus the mu, it's 10, divided by the standard deviation, 3.08, and you get minus 0.81. This is a negative number because it is less than the mean. And the second z-score is 17.5 minus 10 divided by the standard deviation. Then you get a z-score 2.44. And you check the table A1. Then you get the probability for each z-score. And in this case, from this visualization, you can find 29.10% are on the left side, 49.27% are on the right side. So later you want to know the probability between 7 and 18. You need to add them up. And then you get 78.37%. That means 78.37% of the data will be between 7 and 18 if we have next to 200 cars. This is what we have learned: the binomial distribution, the Poisson distribution, the normal distribution, and how to convert binomial distribution into normal approximation. And if you want to get more explanations for your assignments, you can go to YouTube and you can use the keywords to search that: Hanze-IBS-Inductive statistics. Or you can go directly to the blackboard of the university. You go to our course and choose the category Assignments. And on the folder Video Explanations, you can find more video-based explanations to your home assignments. Thanks for your watching.